Commissioned in July of 2011, the City of Lancaster, Ohio's Upper Hocking Water Pollution Control Facility consists of an Evoqua vertical loop reactor and a MemPulse MBR system. Average daily flow of the facility is 2 million gallons per day, with peak capacity of up to 6 million gallons per day.
We're standing at VLR-A, and the influent comes in underground, but comes into this tank. This is an anoxic tank, and so we're removing nitrates here. We're taking advantage of the growth of nitrates in wastewater. The mixer is causing a circular motion in the tank in order to provide the treatment that goes on here. We're standing between the VLR tanks B and C. As you can see, there's a whole lot more aggressive movement with the wastewater, the mixed liquor here. We've got a target of 1 DO in the B tank, target of 2 DO in the C tank. At this point, the mixed liquor is going to leave through this gate and go into the membrane feed channels. These are the membrane tanks. Each of these tanks, there's 272 modules. The membrane feed pumps are pumping continuously into this tank. This tank will filtrate for 12 minutes, and then it's going to go into a relax cycle for a minute. There's a MemPulse that's creating a lot of turbulence around the microfibers in order to keep the mixed liquor from sticking to them.
This computer simulation shows a burst of energy created in a MemPulse MBR module as the large bubble of air produced by MemPulse rises through the module. The two-phase flow created by MemPulse maximizes shear on the membrane surface by creating both upflow and downflow zones around the rising slug of air. In fact, when compared with air scour in conventional MBR systems, known as bubbly flow, MemPulse uses roughly half the aeration energy for the same membrane performance. This is because small bubbles can't provide as much energy to shear off solids and agitate membranes. MemPulse acts like an airlift pump to provide uniform distribution of mixed liquor across the membrane tank. This ensures a well-mixed operating zone, maximizing the life of your plant through optimal operation of all membrane modules in the cell.
The material coming out of the VLRs is right now around 9,500 parts per million, milligram per liter. And the water that's coming out of the filtrate system, we're measuring it with turbidimeters. When I do my EPA report, it's always less than 1 part per million. So it does an absolutely fantastic system. Lancaster started up the membrane system in July of 2011. We have yet to pull a membrane. When we drain the tanks, we get a chance to see the microfibers. There's very, very few where we see breakages. There's very little material that gets stuck underneath the potting material at the top of the fibers. From a mechanical standpoint, this has been a very nice system for us to operate. We started the wastewater treatment plant here, the Upper Hocking, in July of 2011. Of course, now we're in September of 2015. In all of this time, we have had consistent membrane performance. Right now, the permeability in tank number 1 is 9.7, permeability in tank 2, 9.1. The numbers they want us to achieve are around 9 to 10, and over the course of time that we've been operating this, we've always been essentially in that range. One of the things that's required in doing membrane treatment is the chemical clean. We've tried to be very diligent on maintaining those cleans, and I think that has a lot to do with why the system is operating as well as it is. Another component of that is the VLR. VLR provides a very stable biology. I've been in wastewater, I'm in my 21st year with the city, and I was in industrial pretreatment before that. I've gotten to see quite a bit. We were doing master planning in the city back in the early 2000s. We've had issues with combined sewers, which has driven things that we need to do to provide better, basically water to the stream. To do that, we started looking at technologies. The more we looked at the membrane technology, the more that was the technology that we wanted to look at more closely. We started looking at membrane plant. My superintendent went to the Water Academy up in Milwaukee. So we were satisfied that MBR was the route we wanted to go. And then the question was, what about the biology ahead of it? We were looking at one system rather than a component here, will they work? We made a decision to go with the Evoqua integrated system. Over the years, we've learned you can spend a little bit on engineering and not get as good a product, or you can spend a little bit more on engineering and then get a much better product. So we paid a little bit more, I think, for engineering up front, but what was amazing was at the end of the project, and this took well over a year to build, but at the end of the project, I think we had something like 3 change orders, which is almost unheard of. Everything just went very, very well, and we were very pleased with the support that we got from the supplier of the equipment, from the Evoqua people. They were here to help us with the startup. They provided a lot of integration type work with our engineering firm. They spent a lot of time behind the scenes through an internet-based system, operating the system with us when we were first starting it. So it went very, very well, and we were very pleased with the choice that we've made.